that what could be a possible substance. So in the question, we have two substances, solid E is there and solution F. So two substances are there. One is solid E, another one is solution F. So the first part, about half of solid E is placed in a test tube. So we place, like we have solid E, and we place this solid E in a test tube. And then what we did, we heat it gently. We supply the heat energy to the test tube. As a result, what we observe a steam is given off. Remember, whenever steam is given off, what does it mean? It shows that this solid is a hydrated compound. Hydrated compound means it contains water of crystallization. That's why this what the steam is given off. That is actually the water of crystallization. So why the condensation occur at the top of the test tube? What it shows, that gives an idea that solid E is a hydrated compound, or it contains water of crystallization. The second part, the remaining of solid E was dissolved in a distilled water. So these are the tests which are carried out on remaining of a solid E. So it was dissolved in a distilled water, and solution was divided into 4 test tubes. So we have 4 different test tubes which consist of solution of E. To the first one, like test tube, because test 1 is we supply the heat energy and it decomposes because it contains a water of crystallization. It is a hydrated salt. Now test 2, what we did, about 1 cm cube of a dilute nitric acid and few drops of silver nitrate. So this, you have to identify what is this test for. Whenever we add silver nitrate or lead nitrate, a nitric acid followed by silver nitrate or lead nitrate, actually this is a test for halide ion. Like this is used to identify whether chlorine is there, bromine is there, or iodine. So if this does not give a positive result, no visible change. So what this test to indicate? This test to indicate that this compound E does not contain any halogen or no halide ion is present. Then test 3, 1 cm cube of a nitric acid followed by a few drops of barium nitrate. So barium nitrate or barium chloride, when we add to a substance, this is a test for sulfate. When it gives a white precipitate, what it gives identification, it shows that there is a sulfate ion present. Because when we add barium nitrate or barium chloride, the barium ion react with the sulfate ion present in the substance, form barium sulfate, and this barium sulfate will give us white PPT. So white PPT is due to barium sulfate. Then excess of aqueous ammonia is added to a third portion. When we add excess of aqueous ammonia, and what we observe white precipitate. So you have to learn the test for the ions. When we add aqueous ammonia and there is a white PPT in excess of aqueous ammonia, what this gives an idea? This gives an idea that there is aluminum ion, because this is a test. This white PPT confirmed that aluminum sulfate is formed, and this gives an idea that aluminum ion is there, because in excess of aqueous ammonia, aluminum precipitate does not dissolve. If it was a zinc or lead, it will dissolve. Then aqueous sodium hydroxide was added dropwise in excess of a fourth portion of a solution E in the boiling tube. So we are supplying a heat energy. When we add sodium hydroxide and heat, a white precipitate dissolve and it form a colorless solution. So if white PPT is there, gives a colorless solution, this can be a test. This gives an idea. It might be aluminum ion. So it gives an idea. It might be aluminum ion or zinc ion. But because already we identified adding an excess of aqueous ammonia, it was giving a white precipitate. So this confirms that it is not zinc, it is actually aluminum. Because this is a test, the observation for presence of aluminum ion or a zinc ion. Then the test 6, the product of test 5 was warmed. So now we supply heat, a damp red litmus, the red litmus turned blue. The only alkaline gas is ammonia, and ammonia gas is released when we have ammonium ion. So if a salt contains ammonium ion, it will always release ammonia gas when we add alkali and supply heat energy. So state conclusion that can be made from observation of test 1. So what was the test 1? The test 1, we supply the heat energy to the solid. So as you can see in the test 1, we supply the heat energy to a solid, and the solid give off water of the crystallization. So this gives an idea that solid E is a hydrated salt. So what does test 1 indicate? It indicates that the salt is hydrated or contain water of crystallization. What conclusion can you make from observation of test 2? What is test 2? Test 2, we add silver nitrate. As I mentioned, adding a silver nitrate is a test for halide ion. Like it can give a positive result with chloride, bromide, and iodide ion. If it is chloride ion, it will be white PPT. Bromide ion, it will give cream color precipitate, and iodide ion, yellow PPT. But in this, we don't observe anything. So what does it mean? This gives an idea that there is no halide ion or no halide is present, such as chloride, bromide, or iodide. So what conclusion we can write from test 2? We can say does not contain halide or no halide is. So there is no halide ion present in the 6. Then identify 3 ions in solid E. So how we identify the 3 ions which are present in solid E? If you see this test indicate adding a barium nitrate, we get a white PPT. So this test indicate there is a sulfate ion. The test 4 and test 5 indicate there is aluminum ion, because in excess of the aqueous ammonia, the white precipitate of aluminum does not dissolve, and in excess of sodium hydroxide, the white precipitate dissolve. And the test 6 indicate when we supply heat energy, a pungent gas is given off which turn the red litmus paper blue. So this indicates that there is an ammonium ion. So what are the ions present? It contains ammonium ion, it contains aluminum ion, and it contains sulfate ion. So these are the ions which are present. You can write the formula for each ion, or you can mention in word. So I can mention it contains aluminum ion, it contains ammonium ion, and it contains sulfate ion. So these are the 3 ions present in solid E. Then the second substance, the solution F. So solution F is actually sodium hydroxide. So they give you an identification that it is a sodium hydroxide, it is a base or alkali. A flame test is carried out on solution F. So if we have a compound which contains sodium, so what is the color of the flame? So it will be yellow in color. If it contains potassium, it will be lilac. Lithium, it will be red. Then the remaining solution of F was divided into 2 equal portions. To the first portion, few drops of universal indicator is added. So when we have an alkali and we are adding a universal indicator and sodium hydroxide. So what will be the color of indicator? You can mention violet, purple, or you can also mention blue. To the second portion, we add copper 2 sulfate. So remember, whenever a solution contain a copper ion, like copper to sulfate means it contain copper ion and sulfate ion. And what we did, we add solution F. But what is solution F? Solution F is sodium hydroxide. So when sodium hydroxide mixed with the copper ions, it will produce copper hydroxide. So what will be the observation whenever copper hydroxide is there or copper ion mixed with alkali? So it will give us blue PPT. And approximately 2 cm cube of copper sulfate was added. So small quantity is added. So we will get a blue PPT. If we add excess of aqueous ammonia, then what will happen? It will, like in excess of aqueous ammonia, copper will dissolve and give a deep blue solution. But in the presence of sodium hydroxide, it will always give us the blue PPT. Normally, the last question is about the planning of experiment. You have to plan an experiment. Depending on like different types of experiment they can ask. Normally, like rate of reaction is common, and reaction of acid and alkali preparing a salt, and chromatography. These are common experiment. You will find repetition as well. Now, dilute hydrochloric acid reacted with calcium carbonate to make carbon dioxide. So this is giving off carbon dioxide gas. The apparatus shown in a diagram can be used to follow the progress of a reaction, like how the reaction proceed or measuring a rate or the speed of a reaction. The carbon dioxide gas leaves the flask, causing the mass shown of in a balance to decrease. So what happened when acid, hydrochloric acid react with carbonate, it will give salt, water, and carbon dioxide. So that carbon dioxide gas will escape, passes through this mineral wool or cotton wool, and the mass on the balance, because the gas escapes, so the mass on the balance will decrease. What we have to do, we have to plan an investigation, like plan an experiment using the apparatus shown. So this, using this apparatus, we have to plan an experiment to find out the temperature of a dilute hydrochloric, how the temperature of a dilute hydrochloric acid affects the rate of the reaction. And your plan should include how your result will show how the temperature of a dilute hydrochloric acid affect the rate of reaction. You are provided with a dilute hydrochloric acid, you have calcium carbonate. So basically we have to plan an experiment to find how temperature affects the rate of the reaction. So how we measure the rate of this reaction, because here the mass is decreasing. So we'll measure the change in mass after certain time interval until the mass is constant. Once the mass is constant, it means the rate of the reaction is like the reaction has stopped. And then we will repeat the experiment with different temperatures, like changing a temperature, either increase the temperature or decrease the temperature, but we'll change the temperature to identify the effect. So first, what we will do, the steps. First thing, we should mention how we measure the rate or the speed of this reaction. So we'll take a measured volume of acid, like take measured volumes, example 10 cm cube of acid, because you're finding the effect of temperature on the rate of the reaction. So all the other parameters should be same, like size of calcium carbonate, mass of calcium carbonate, amount of acid, concentration of acid, all should be same. So first what we'll do, we'll take, like example 10 cm cube of acid. And it's better you mention the apparatus as well, like how you will take 10 cm cube of acid. So we can mention by using measuring cylinder, or if you want to transfer quickly, we prefer to use measuring cylinder. If we want to accurate measurement, like if volume can affect the rate, so we should use a pipette or a burette. But pipette I cannot use here because we have like in a lab 25 cm cube pipette is more common. There is 10, but 25 is the common one. So take 10 cm cube of acid by measuring cylinder. And we'll transfer it into conical flask. That is first step. Then what we'll do, we'll measure the mass of calcium carbonate because we should take equal mass, like say 2 grams of calcium carbonate, as in the question they don't mention what mass is there, like they do not specify what mass we are taking. So we can mention any mass. So the second part, we can mention major mass or of calcium carbonate by balance. Then we will mix calcium carbonate with hydrochloric acid and start the timer, the stopwatch. Then after starting a timer, because we want to measure the rate or the speed of the reaction, how it is affected by temperature. So we should measure the initial temperature as well. I should mention, because I should know what is the temperature. So measure the temperature of acid. By thermometer. Then we will mix calcium carbonate with hydrochloric acid. We'll start the timer. And we will measure the change in the mass. At regular time intervals until the mass of content in the flask does not change. Like when the mass in the content in the flask, the mass is not changing, it means the reaction completed or the reaction stops. Then what we should do, because we should now we should change the temperature and repeat the experiment. With different temperature readings, or higher temperature or lower temperature. And the last part, now how we present our result, how we know like which reaction is faster, which reaction is slower. So we can plot a graph between mass and time, and the one which is steeper. So first we take 10 cm cube of acid, measure by measuring cylinder and transfer to conical flask. Then we measure the mass of calcium carbonate by balance. Then we measure the temperature of acid by thermometer. Then we mix calcium carbonate with hydrochloric acid and start the timer. Then we measure the mass at regular interval until the mass of a content in the flask does not change. It means the reaction stop. And then we repeat the experiment with different temperatures. And then how we conclude this? So we will plot a graph between mass and time and the experiment which shows steeper slope is the fastest. So the one which is steeper, we don't have to plot graph, we just have to mention how we conclude, how we reach the conclusion for the experiment. So how we identify like which reaction is faster, which reaction is slower. So on our graph, the one which is steeper, and remember, because this is change in the mass, so it will always start with a maximum value. So it starts with a maximum value and it will decrease. But the one which is we are using a high temperature, that will like change it faster. So like example, if this is done at 30 degrees and this is done at 20, so at 30 the reaction complete in a short time as compared to that of 20. But you don't have to plot graph, you just have to mention. If you want to plot, you want to sketch, that is also good, that you explain your answer so that you will not lose any mark.